Last point we see the uses of dimensional analysis, and we find out the first use of dimensional analysis. So first use is to check the correctness of physical equations, and we find out the LHS is equal to RHS, and you get V is equal to U plus PT. Now our second use of dimensional analysis is to establish the relationship between related physical quantities. Now related physical quantities we find out. So the period T of oscillations of a simple pendulum. All of us know that the simple pendulum means a bob is connected to the massless, weightless string which supported one end of the string is connected to the rigid support, and its motion is to and fro motion. So it's called a oscillation motion, and this is called this system is called a simple pendulum. Okay. So now T is the oscillations of a simple pendulum. So oscillations of the simple period of the oscillation of the simple means capital T. It's called a periodic time also. So it depends on length and acceleration due to gravity, means small g. So let us derive the relations between T, L and G, means time, length and acceleration due to gravity. So suppose T is directly proportional to the L suffix of A, and T is directly proportional to the G suffix of B. So therefore here we find out these values of suffix first, and then find out what is the relation between T, L and G. So therefore T is directly proportional to the L square and G B. L suffix of A and G suffix of B. Okay, so T is directly proportional to the L means length suffix of A and acceleration due to gravity with the suffix of B. So therefore T is equal to KL suffix of A into G suffix of B, means proportionality constant is called a K. So where K is constant of proportionality and it is dimensionless quantity, means either K is constant, so is no dimension for this value, and A and B are rational numbers. So rational numbers have also not any dimension. So equating dimensions of both sides, so T is equal to K, L suffix of A, G suffix of B. So we know that the dimension of T, so T means time, periodic time. So here we get only T1, means M0, L0, T1. We already find out what is the dimensions, and its dimension is LMT form. Now we also written in MLT form, any form, means L is first of all, and then M on that point, and then T, and we also written in this form MLT form and also LMT form. Both are corrected. Okay, so square bracket, in this square bracket M0, L0, T1 is exactly equal to K, and L means length. So here M0, L1 and T0 the dimension of L means length, and in square bracket suffix of A, and to multiply by acceleration due to gravity, means dimension of acceleration due to gravity. We know that the formula for acceleration due to gravity means meter per second square. So meter measurement in length and second square, so time is 2 and is numerator, so we get here inverse quantity is minus 2. So meter per second square, so we find out the dimension for the acceleration due to gravity is m0 l1 t minus 2 suffix of b. मी थोडं मराठीत सुद्धा म्हणते म्हणजे सगळ्या स्टुडंटना नीट समजेल आर्टिकल. इथे टी इज टाइम पिरियड आहे आणि के इज कॉन्स्टंट टर्म आहे आणि एल इज द लेंथ आहे आणि जी इज एक्सलेरेशन ड्यू टू ग्रॅव्हिटी. एक्सलेरेशन ड्यू टू ग्रॅव्हिटी आपण फॉर्म्युला बघितला आहे, एसआय युनिट फॉर्म्युला बघितला आहे ह्याचा मीटर पर सेकंड स्क्वेअर. सो मीटर पर सेकंड स्क्वेअरचं आपण डायमेन्शन काढताना मीटरसाठी लेंथ मेजरमेंट करतो आणि टाईमसाठी सेकंड. सो इन्व्हर्स क्वांटिटी आहे मीटर पर सेकंड स्क्वेअर. इथेच लिहिते मी मीटर पर सेकंड स्क्वेअर फॉर्म्युला. तुम्ही लिहिताना हे लिहू नका, डायरेक्टली इक्वेशन लिहा, हे तुमच्या माहितीसाठी आहे. सो एम पर मीटर सेकंड स्क्वेअर, सो डायमेन्शन फॉर एम इज L1, dimension for second is t 2 and here inverse quantity, so we get here minus 2. Got it? समजलं? So पुढे जाऊया. So now written in the m0 l0 t minus 1 in square bracket, therefore k is equal to m0, now here suffix, so m0, so suffix of m is also 0 and then here l1, so l1 is la plus lb, so we get here L a plus b and t is equal to 0 and t is equal to minus 2b, so we get here only t is equal to minus 2b. हे तर इझी आहे, हे समजेलच. त्यानंतर आपण बोथ साइड्स इक्वेटिंग करूया सफिक्स. ओके, सो हियर इक्वेटिंग दिस सफिक्स m0 m0 l0 and here l is equal to a plus b, so we can write here a plus b is equal to 0 and minus 2b is equal to here 1, comparing this suffix. Okay, so here solving this term, a is equal to we get minus b and b is equal to minus half, so we get here term b is equal to minus half. So put up the value of b in this equation and we get a is equal to minus of minus a half, we get means a is equal to plus half. So here we get a is equal to plus half and b is equal to minus half. So all two suffix we have find out, we put up in this equation. So we get here our equation is t is equal to k l, a suffix of a, and g suffix of b, means a is we find out a plus b and g find out means b find out a minus half. So put up the values of a and b. So we get here t is equal to k l raised to half and g raised to minus half. So half and minus half means here half represent a square root and we only represent square, so we get here squaring term. So here half means square root term. So we get here t is equal to k is constant, proportionality constant, in the root of l is half, so in numerator, and g is minus half, so we get here reciprocal values, means is denominator. So here t is equal to k root of l upon g. This is the relation between periodic time, length and acceleration due to gravity in a simple pendulum. So here t is called a value of formula for the periodic time of simple pendulum. Okay, so the value of k is determined experimentally and is found to be 2 pi. ओके, ऑलरेडी फाइंड आउट केलेली आहे व्हॅल्यू 2 पाय ची एक्सपेरिमेंटने आणि ती आपण आता पुटअप करतो. सो वी गेट हियर टी इज इक्वल टू 2 पाय रूट ऑफ एल अपॉन जी. ओके, सो वी गेट हियर relation. This is the use of dimensional analysis to establish the relationship between related physical quantities. So we prove the second use of dimensional analysis. Already we learned first use and now here second use. Next point we find out the third use. Okay.